I'm glad to present you about who we are, how much we have evolved as a company over the last 25 years. DEP has 4 different verticals of business, and we do engineering service and work with most of the OEMs. We have been supporting them by setting their dedicated ODC for different customers. We have also supported them on the CAE turnkey projects. We have developed both software product, which is the MeshWorks, and a bit of hardware-based development also. DEP also has supported most companies with skilled engineers. We place them on site at their premises. We are headquartered at Michigan, Troy. Today, we are about 550 plus employees worldwide. We are blessed to have the top-notch talent engineers who are the backbone of DEP. We support multi-industries from automotive, aerospace, defense, medical, oil and gas, heavy machineries, electronics, and consumer products. DEP has come a long way since its inception in the year 1998. The vision and the mission of the company is very much customer focused. We have accelerated your product development at the same time optimize it. These are some of the partial customer list with whom we have been working for the last 25 years. Now I hand over the stage to Abdul, who is our MeshWorks certified technical lead. The stage is yours, Abdul.
Thank you, Sudarshan. Can you stop sharing, Sudarshan, so that I'll share my screen? Yeah, let me share my screen. So let me pull in the slides and continue where Sudarshan have left them. Good afternoon, India zone, and also good morning, Europe zone. So I'm Abdul Halim, joining from India office. I'm taking care of all the pre-sales support activities for the Asia Pacific zone. As you saw, like we had a nice introduction about the DEP from Sudarshan. So I'm here to present one of our greatest product, MeshWorks from DEP. So this session is going to be directly involved into MeshWorks, in depth what MeshWorks is. Okay. So MeshWorks is a complete integrated CAE platform, so which is involved in all the different verticals of domains, something like automobile, aerospace, ship industries, oil and gas, then biomedical industries, heavy industries, logistics, and also now electronics as well. So all these verticals, DEP MeshWorks has been supporting as a CAE platform. And our main highlights of MeshWorks is these 10 modules. So starting from as a preprocessor tool, so starting from meshing and modeling, post-processing, morphing, time saving in MDO, then highly automated process automation workflows, and AML, and some of the unique toolsets, something like ConceptWorks or patented technologies of Rome and Product Electrification Module. I am going to give a glimpse about all these 5 to 10 topics here, and directly dive into those individual slides and give you a brief about all those what it is in MeshWorks. So when it comes to MeshWorks, so as a product development cycle, like whenever it comes to a new product development, so starting from the initial stage of the conceptual stage to the maintenance state, like where the detailed phase will be there and virtual validation phase will be there and the maintenance phase will be there. So there is a new product development and a older product development cycle. So in the older product development cycle, you can able to see directly, like we can see a lot of time spent over in the detailed validation state and virtual validation and maintenance phases. So why? Because there is no time has been spent or no much involvement has been made in the conceptual stage itself. So here in MeshWorks, we are giving upper hand where like the user can spend his time in the conceptual stage itself by doing all the type of modifications, creating his own geometrical designs, etc., etc. From there till the maintenance phase, so we can able to use only less tools when it comes to detailed virtual validation and maintenance phases. So there is less time of man effort is needed here in MeshWorks usage. So our whole point and idea here to convey you is like, so with MeshWorks, how one can able to save a lot of time in pre-processing, post-processing, and conceptual design stages. So in conceptual stages, like MeshWorks is like giving a hands in concept works and also some morphing modules. And in the detail phase, like MeshWorks parametric CAE modules and topology optimization modules in a component level or an assembly level of components. And MeshWorks rapid meshing and modeling modules will be giving a hand over all the different validation stages. So that is our main intention of today's presentation. So with that, I'll start with the first, so which is our meshing and modeling. So whereas in like when it comes to meshing as a pre-processing tool, like we have automated all the different kinds of verticals of meshing with our machine learning algorithm integrated into it, starting from tetra meshing, be it a plastics or a sheet metal or a hexa modeling, so whatever it is. So you take it, so all the different set of meshing has been completely automated, and it has been extensively benchmarked and produce a high quality standard rich mesh outputs. So once after you do the meshing, obviously like you need to go for the modeling. But when it comes to meshing, so what are the values like you can able to expect from MeshWorks is like one doesn't need to do any kind of a CAD cleanup in the prior stages. So user can directly take the CAD in and go for the meshing. And if at all the CAD is bad, you can go at, for the auto cleanup methods in MeshWorks. And it will give you a lot of turnaround time in a huge way as an impact when it comes to doing the meshing directly on hands by the engineers. And all type of different meshings in one roof. There is no need of switching into multiple softwares. So you can just club into one particular tool for all the type of meshings, and cost and time benefits here. And of course, like you can able to see 30 to 50% of time reduction across all the variant of meshing modules here. So once after you do the meshing, obviously like you need to do the modeling. So when it comes to modeling as well, like we have completely automated a lot of modeling approaches, starting from welding. So when it comes to sheet metal meshing and you wanted to do the connections, so all you just need to do is just select the assembly of components and just give the welds, and directly you can produce the quad welds or the V quads or the rigid welds, whatever the type it may be. You can able to weld it across all the components automatically. And also not only for the sheet metal parts, like if at all it's a 3D part, like you wanted to create any kind of a seam welding or any kind of a 3D welding, so which is need to be created across a different set of combinations. For example, if the user wants to create different set of combinations, something like tetra to tetra as a tetra weld or a hexa weld, so hexa and tetra components. So whatever the combination is, whatever the profile is, the user can able to create welds automatically in MeshWorks. And so across like be it a full vehicle model or like a component level, so one can able to create any kind of weldings and adhesives, all the types of connections, be it like you can able to create it in MeshWorks. And also the we have gone a step ahead. So when it comes to bolting any kind of a 3D component, something like we have a templatized based auto bolting functionalities, where one can able to create 1D bolt or a 3D bolt directly on a 3D parts. And once you create bolts, like if at all the user wants to create a contact over the 3D bolts, like what if the user wants to connect the bolts with the 3D parts, so that also automatically the tool will take care of it. So here you can able to see the bolt specifications which the user can give in, and you can able to create the 3D bolts directly into it. And you can also define the contacts over the 3D bolts, whatever you are creating inside. So you can clearly see like how the user can create a 3D bolt. So for creating one 3D bolt, manual time would be, you can imagine it. So, and also so once after creating a 3D bolt, the pretension, or be it a head component contact or a shank component contact, so you can able to create it automatically in MeshWorks. So not only that, be it a component level or an assembly level, one can able to create a contact surfaces and attach the components and give the interactions together over the multiple components, can be done automatically in MeshWorks as well. And one more big advantage in meshing and modeling functionality is, so once you do the meshing in MeshWorks or create a contact or create a connection in MeshWorks, you can completely parameterize it. For example, like if, let's say, this kind of a spot weld location, so if the user wants to parameterize this welds, so he can specify the length of the weld or the width of the weld or number of welds in this particular region. So whatever it is, the user can able to perform the parameters on. So you can imagine like in full vehicle model, like more than thousands of welds will be there, which will save a lot of time in this kind of a parametric approach. Time and also weight in this kind of a parametric approach. So moving on to the next topic after the meshing and modeling. As I told before, so these are the main advantages and values once after you do the modeling in MeshWorks. So you can able to save a lot of time in model assembly as an assembly process of doing the connections. And also you can able to create any kind of a unique connections throughout all the different verticals of the components. And also the accuracy of the meshes, when it comes to 3D welding, like we have heat affected zone creation over the 3D welding, which will give you the accuracy of the results over the heat propagation studies. And also here as well, like we do clearly give you a 60% of time saving and time reduction over the manual effort. So this is how like we reduce a lot of time in meshing and modeling functions. So once after you do the meshing and modeling, like we do enter into the post-processing. So when it comes to post-processing, all the animations, contours, or measuring modules, or the cut sections, so these kind of a detailing regular based tools are already being rich enhanced in MeshWorks. Apart from that, like what is very unique in MeshWorks is like we do give an automated tool sets inside post-processing as well. For example, we do have our hotspot extraction tool here, where the user can just extract his own results, and directly he can able to export those results into the pre-processing window, and he can perform the parameters directly onto this particular components to clear any kind of failure regions or hotspot regions. As I told you earlier, like when you do the meshing or modeling in MeshWorks, like you can able to perform parameterization into it directly. So this is one of the good example for that. Like once you import all the component into the pre-processing window, so one can able to perform this kind of super cool parameters, something like fillet radius change or a tube diameter change, width change, height change, etc., directly onto the MeshWorks window. So without even knowing like what is morphing, like one doesn't need to learn what is morphing here. So he can directly pitch in and he can able to create these parameters and make this design pass. So that good and that efficient and also that accelerated it is to do the post-processing in MeshWorks. And also not only that, so for the tetra components, you saw the auto parameterization similar way. So we do have morphing and parameterization for the sheet metal, hexa. So be it any kind of a domain, you have the parameterization integrated into MeshWorks. And you can able to achieve this kind of a shape changes with our advanced morphing, so which I will talk in upcoming slides. So apart from the shape changes, if the user wants to integrate any kind of new features and make the model strengthen in more, like we have a lot of design solutions and design enablers. For example, this kind of 3D ribs or sketching the ribs, like for the user's desired profile. If the user wants to sketch a rib directly onto a cross section, just he can specify the start point, end point, and directly sketch the cross section and create a rib over the component. And not only that, like once after you create a rib, if you wanted to insert any kind of a patterns, like for example, this kind of a honeycomb structure for speaker grill, or strengthening this zones, like if the user want to create more features into it, yeah, we do have multiple options, something like this, to create it instantly over it. So these are all some of the design enablers, so which you can able to see. So that is what very unique to MeshWorks in here. And so what is the value of the post-processing is, as I told before, like we have multi-disciplinary post-processor where you can import in, like be it an Ashland template, a Abacus, or a Dyna template. So whatever it is, you can import it here and you can able to perform your post-processing. And once you extract the results, obviously, like you can able to achieve the gooder products from it, and you can able to perform the auto parameterization into it. And you can add in multiple shape parameterization or design enablers or something like that. You can able to integrate into. And most over that, like we have a rich industrial standards of post-processing features in animation, contours, etc. And apart from that, like we do integrate our auto hotspot extraction tool, which you saw already in a video. And most unique tool, something like that, is like directly, like whenever you can able to extract the results, you can publish this as a PPT, as a web HTML document. So which is an advantage for the post-processing users. Okay. So when it comes to machine modeling and post-processing, you have seen a lot of time saving and also a lot of unique tool sets. Like you can also still accelerate your time with our process automation functions, where like the user can able to automate his own DDS process. So something like his own unique day in and out routine of process, one can able to automate it with just a 4-step process. So all you need to do is just record the process, where the user doesn't need to learn any kind of a Python or a TCL/TK scripts, etc. here. So user can directly record the process, like whatever he is manually following, and he can able to create a panel or a GUI for your own benefit, and then you can club the process and the panel, and then you can create your own process automation and publish it to the users. So that is how easy the user can able to create a process automation in MeshWorks. So we have an integrated set of 60 plus process automation, which has already been integrated into MeshWorks. It is along with MeshWorks, you can get it as well. And what is the use of process automation? As I told before, so you can accelerate your time furthermore. Apart from your machine time reduction and modeling time reduction, you can accelerate your timing furthermore. And also, like, it is very easy to use process automation functionality, which you can able to see it in MeshWorks. And as I told before, like, one doesn't need to learn any kind of scripting languages for this. And apart from that, like, another thing is, like, from the extensive of CAD to CAE, like, one can able to create a process automation from start to end. Okay, so moving on to the next topic, which is the morphing. So MeshWorks has been called widely globally as a morpher a decade ago, because, like, we have been leaders in morphing for many years. And so now we have enhanced our morphing capabilities furthermore. And also like we are in advanced stages of morphing. So now I'm going to show something like advanced morphing. Like, so before, like we used to have our generic morphing, something like a nodal based or a block based or something like that. But in this case, like I'm just showing you some extraction of within just extraction of the cross-sectional profiles for a rocker region or a sub-member, something like this. One can able to just do all the modifications in the cross-sectional level itself. So be it a width change or a height change. So whatever it is, the user can able to do all the modifications in the cross-sectional level itself. So where it will give you more accelerated time, and also it is very easy for the user to do this kind of a morphing. So once after you do morph the component, so what happens is like automatically it converts the normal model into a morphed model. Along with it, like you can able to observe the nearby adjacent parts, like which has been connected to the original component, that also being accounted into this kind of a morphing approach. So that is how advanced like we are approaching the morphing, and also like it has been integrated as a component level and as an assembly level, and also like a different set of verticals, so which you can see in much detail in individual presentations over these kind of topics. Okay. So when it comes to morphing, so after morphing, like so this kind of a shape changes everything, like in any kind of industry verticals. Let's take human factor ergonomics or something like a dummy positioning or a dummy seating, or any kind of a manufacturability processes and vehicle packaging statuses, and also like new facelifts, like which you produce it in OEMs, and also some structural CFD performances. In this, all these verticals, one can able to parameterize the models in all these different set of domains. So starting from shape parameters, gauge and materials, welds, adhesives, features, and special parameters, something like part extension or weld parameters, etc., etc. So all these one can able to parameterize in MeshWorks. So with morphing and also parameterization, shaking into hand together, you can able to achieve the MDO, so which is the multidisciplinary optimization. So from one particular vertical of a baseline design, like one can able to take either it's a durability design, you can able to take it into MeshWorks as an account. You can create multiple set of parameters and create a designs of its own. So one particular domain one can able to import, and you can apply it for all the different verticals. And then he can able to create an input-output matrix table. Then we can able to send this input-output matrix table to a optimizer tool, be it a More Frontier or a eyesight tool. So whatever it is, you can integrate it with MeshWorks, and you can able to achieve the response of its calculation and then get the optimized design. So that is how like we can able to achieve MDO using the morphing and parameterization approach. This is all for the assembly level and also the full vehicle level. What if it's in component level? So in the component level of a time saving, like one can able to optimize the component with a topology optimization approach. So where he can able to pull in the model and make it a minimalistic design. So reduce all the thickness, remove the ribs. So we have the tool sets for that. Remove the features, you have the tool sets for that. And then you create a like a design approach, like where the topology run has been performed, and then give you the result, something like where the features need to be added or removed, something like that. The user will be getting a results. So from the results, if the user want to add in a rib or reduce the thickness or increase the thickness, whatever it is, the user can do it with MeshWorks. So this is how we optimize one particular single component from starting from scratch to end as an optimized design. And then comes our unique functionalities in MeshWorks I wanted to cover. So one is our recent AML CAE framework. So this is very unique, wherein like whenever like the user has built their models and then sent for the analysis, and after the analysis results, he will be getting the output as the results for the stress strain curves, etc., etc. So without even doing the solving, one can able to predict the results. So that is where like we bring in this AML technology. So wherein like we learn and we teach our MeshWorks and also our machines with a lot of data accumulations, starting from operational data or an engineering data or sensors, like whatever you have it, or an unstructured data, even like small written notes. You can able to take it into account and you can accumulate its data. And then from there, like we do generate multiple design models. So math model generation or AI deep learning models, and also non-linear parametric models. So all those one able to import it here. And with that, we can able to achieve the convolutional neural networking scheme. So where one can able to deliver the final output model, and wherein like you can import any set of model and you can able to create any kind of a parameter or a shape change, whatever it is, immediately and effectively one can able to view the results on the MeshWorks window directly without even solving the model. So this prediction is around like 80 to 90% of the accuracy we can able to get it via AML framework. So after that, like one of our patented technology, which is our ConceptWorks module. So wherein like one can able to sketch and able to create the cross-sectional profiles, and also any kind of a members or any kind of like a 3D structures directly from the scratch without even CAD design. So one can able to start from the node sketching, and he can able to create his own designs directly into it. So that is how we can able to achieve the designs multiple without even CAD route. And this can be able to performed in sheet metal, tetra, or plastics in any kind of concept modeling. So we can dive into deep in our upcoming sessions for this kind of live demos. And moving on to the next. So you have seen about like our time saving in meshing, modeling, and morphing, etc., etc. And we also give you upper hand over the solving time saving here, which is like converting your 3D models into 1D models for the solving. So wherein like 2 days of runtime can be reduced into 2 hours. So wherein like you convert the 3D models into 1D models in MeshWorks directly with our ROM approach, which is called reduced order model, and where the user can able to create the 1D models, and then he can able to do all the optimization like morphing, parameterization, or he can able to do the MDO, then component level or extensive of assembly level, whatever it is. So then he can able to generate again from the 1D model to 3D model something with our ConceptWorks tool sets. So this is all like entire workflow. We do give it to the users. And also like if the user wants to perform the simulation for the front end for the crash, and he wanted to completely neglect the rear end, so we can able to convert the rear end as a ROM module model, and also like the similar way for the crash for the side impact as well. So these are all like we give a quick turnaround time for the runtime, which is being saved more than 50% of solving time, and also like the accuracy of the results, everything has been enriched. So this is on our ROM module, and at last is our product electrification module. So I'll just quickly touch upon this our new module, which is where like you can able to see our industry standards, where it has been going ahead about electric path of converting the conventional vehicles into an electric vehicles. So one can able to do all the machine modeling, performing simulations and the ConceptWorks, etc., everything for the electrical domain. So we have it set as a separate domain for as a module in MeshWorks. So you can able to see like how one can able to perform all the different operations. Of for example, this particular example is converting the entire conventional vehicle, where we have this drivetrain path and all, like which can be completely converted for a battery pack thing, and you can able to achieve in no time. Like, so we have the separate module which has been developed only for the electrical vehicles. And at last, as a conclusion, like we can able to see all the different modules in MeshWorks, so which has been not missed out at all. and also you can able to save a huge amount of time saving machine time also manually. And also like when it comes to DEP MeshWorks, we do categorize ourselves as transform, accelerate, automate, and innovate. To give a glimpse, like transforming like components or any kind of a modeling into a CAE CAD morphing or a CAD. So whatever the morphing approach we can get into concept modeling or whatever it is. So it is all like transforming your own CAE conventional CAE approach into a different domain. And accelerating is additionally like we are giving an upper hand over like accelerated workflows, something like a ROM modeling, like converting your 3D model to 1D models and 1D model to 3D model, etc., where you can save a lot of time, like 30 to 70% of a manual time. And then like you automate, like how one can able to automate his own already finalized process can be automated, and you can able to see the time differences more than 50% there. And innovation is like whenever we grow, we also grow along with our competitors. We do extensive benchmarks and we innovate something very new and give it to the market. So in that case, like we have our EMOD functionality, be it a ROM module or a ConceptWorks module, whatever it is, like we are patented and also very unique, and we are innovative to those approaches. So with that, I'll conclude my session. So I'll leave the stage to any question and answers right away. So thank you all. So I'll just wait for the questions.
Abdul, you can put on that slide over the screen. Yeah.
So any question pop-ups, you let me know, Ilan, like because I'll not know.
Yeah, sure, Abdul. So the audience can use the Q&A option available in their window, and they can type out their questions, or they can ask to unmute so that we can unmute you. Okay, Abdul, we got a question regarding how much benchmarking is done and what kind of detailed information that we can get on each of these modules. Do you want to answer it with the information about our upcoming sessions?
Yes. Actually, like so when it comes to benchmarking, like we are pretty much confidential, but still it is some of the things like which has been already sanitized. And in upcoming sessions, like we are going to give you a in-depth like a live demonstrations over the competitors, and also like how we are very unique and distinct. We wanted to prove ourselves with our live demo sessions as well. So in those sessions, like you will be seeing all those upcoming versions.
Okay, I think, if there are any more questions from the audience, they can actually write to the details. Abdul, can you show the contact information slide? The last slide. Okay. So the email IDs are available. Any queries or clarifications, the audience can write to this email. So with that, we can close the session, Abdul. Thank you.
Sure. Yeah. Thank you all for joining the session. Have a great day. Bye-bye.